All right, 9-4, triangles. What you're going to learn is you're going to find the missing angle measures of a triangle, and you're going to learn how to classify triangles by their angles and by their sides. Again, you'll see a nice long list of vocabulary for this section. But again, I like section 9-3. I think you know many of these definitions. For instance, line segment. A line segment, maybe you don't know line segment, has two endpoints, and it's all the points in between. So for instance, here's an endpoint, and here's an endpoint, and it's all the points in between that create the line segment. And this line segment we would call EF. And it would be written line segment EF. Notice no arrows on this bar that's above line segment EF. A triangle, next definition. A triangle is a shape formed by three line segments intersecting at their endpoints. So I have a line segment here, right? I have a line segment here, intersecting at the endpoints, and I have a line segment here, intersecting at their endpoints. Three line segments intersecting at their endpoints, a triangle. Okay, here's another picture. Each pair of segments formed an angle, right? This pair of line segments forms this angle. This pair of line segments forms another angle. And this pair of line segments form a third angle. And the vertex of each angle is the vertex of the triangle. So these points that we learned as vertexes just for angles are also the vertexes of the triangles. And here we know to get a new word. The plural of vertex is vertices. Triangles are named by the letters of their vertices. So triangle XYZ is written triangle XYZ, right? And it has sides. From this I can tell it has segment X, excuse me. It has line segment XY. It has line segment YZ. And it has, line segment XZ. The vertices I know are X, Y, and Z. And the angles are angle X, angle Y, and angle Z. So I want you to be able to identify by looking at triangle XYZ. I want you to be able to tell me what are the sides, what are the vertices, and what are the angles. For instance, what if we have triangle QRS? What will be my line segments? Line segments will be QR, here and here, here and here, right? It would also be R and S, and it would also be S and Q. Okay? What would my vertices be? Vertices would be Q, R, and S. And what are the angles? It would be angle Q, angle R, and angle S. Okay? Well, somehow we have two of these, so we can skip that one. Yay. All right. An interesting thing to note that the sum of all the measures of a triangle equals 180 degrees. Always. For those of you who sometimes ask me always, always. The sum of the measures of the triangle, if I have this triangle, here we have it, I'll draw just a little bigger, X, Y, and Z degrees, right? These are all measured in degrees and measure the angles. Well, the sum of this the sum of the measures, x plus y plus z, equals 180 degrees. Always. If you took this angle right here and drew it here, you took this angle right here and you drew it here, and you took this angle and you drew it here, you would see that they all add up to 180 degrees. Always. And that means we can solve some problems if we know this equation. And here's a problem. Find the value of x in ABC. Triangle Triangle ABC. Well, we know the measure of angle A plus the measure of angle B plus the measure of angle C always equals 180 degrees. So we can substitute what we know. We know the measure of angle B is 58 degrees. We know the measure of angle C is 55 degrees. So we can solve for x. Add these two together, we get 58 and 55 is 113. X plus 113 equals 180. Do a little algebra, subtract 113 from both sides, and you find out that x equals 7. So the measure of angle A is 67 degrees. You can use ratios to figure out measures of angles as well. For instance, what if we know the measures of the angles of a certain triangle are in the ratio of 1 to 4 to 7? We can find the measure of the angles. Well, you know what? I'm going to draw a picture because I like to draw pictures to help myself with geometry. So one angle, and the ratio is 1 to 4 to 7. We're going to let x represent the measure of one angle. Here it is, x. So that angle is x. This one is 4 times this one, isn't it? The ratio is 1 to 4. So if this one is 1, this would be 4. So if this is x, this must be 4x. And this is 7 times as big, the other angle. So this would be 7x. So if you know the ratio 1 to 4 to 7, you know it's 1x plus 4x plus 7x equals what? What do all the measures of a triangle equal? 180. So I add all my x's together. 1x plus 4x is 5x plus 7x is 12x equals 180. Divide both sides by 12. And let me get my handy dandy calculator out because why not, right? 180 divided by 12 is 15. Thank you. Some of you probably already had that. I'm just a little slow here. So x equals 15. That means this measure right here is 15 degrees. How about this angle? What is it going to measure? 4x, right? So 4 times x, which we now know is 15, will be 4 times 5 is 20, carry your 2, 4, it will be 60 degrees. So this one equals 60 degrees. Now, you could either do 7x or 7 times 15, and you could find out what your last measure equals. And 7 times 5 is 35. Carry your 3. It's a 105. So this angle measures 105. And we found the measure of all 3 angles just by knowing the ratio of the measures. Just kidding on that. We will cancel that out. Triangles can also be classified by their sides. Congruent sides have the same length. So remember that congruent means do we remember what congruent means? Congruent means equal measure. All right. And the symbol for congruent is that guy, don't forget. Equal measure. All right. A scalene, so we're classifying triangles by their sides first. A scalene triangle, and yes, you need to be able to spell it and pronounce it, scalene, has no congruent sides. An isosceles has at least 2 congruent sides, and these marks right here mean that the sides are congruent. An equilateral triangle has all sides congruent. This should be review for you guys. We can also classify triangles by their angles. All triangles have at least 2 acute angles, you'll notice. So an acute triangle has all acute angles. All angles are acute. An obtuse triangle has 1 obtuse angle. And a right triangle has 1 right angle. So we can classify triangles by their sides and by their angles. Here is your guided practice. Go ahead and try that. And you'll notice there's classifying. Remember, you have to classify by angles and by sides. You have to find the value of x in the first ones. And here you have a ratio, and you have to find the measures of all the angles. You may want to go back and review that one section and watch that problem again. Good luck with it.